Welcome to the design topic of our software design and development unit. Here are our learning intentions for today. We will learn how written and graphical design notations are used to plan and describe a program. Here is our success criteria. We will be able to describe what a design notation is and what it's used for. We'll be able to write a design for a section of code using pseudocode. We will be able to draw a design for a section of code using a data flow diagram and a structure diagram. And finally, we'll be able to draw a user interface for a program using a wireframe. As always, our learning intentions and success criteria should be referred to throughout the lesson. When planning a program or a software solution, the developer must identify the data flow within the program, the variables that will be used, and the constructs that will be required to create a solution. They will make use of a variety of design notations to help them do this. There are many different types of design notation available to developers. Some are more useful for certain aspects of design than others. Four main design notations that we will look at are pseudocode, data flow diagrams, structured diagrams, and wireframes. The first design notation we will look at is pseudocode. Pseudocode lays out the detail of how the program will work. It sets out the structure of the program into key steps. It also breaks those key steps down into refinements where the key steps are broken down into smaller, more manageable problems. As with the example we see here, pseudocode is written in plain language rather than any specific programming language. Let's take this example and look at it in a little more detail. There is no specific syntax for pseudocode, but there are some keywords which indicate different aspects, such as variable declarations, input and assignment, output, selection constructs, and iteration constructs. Let's look at some of these now. The declare keyword is used for variable declaration. The next keyword is receive, which is used for input. Our program will receive password from the keyboard. We then have an iteration construct, the while keyword. So this is a while loop. While password is not computing. We then have an output keyword in send. Send password correct to display. Another iteration keyword is repeat. This keyword would be used for a fixed loop. Repeat loop 10 times. The keyword for assignment is set. Set average to total divided by 10. And finally, we have our selection keyword, if, in our if statement. If average is greater than 100. As we've seen, these keywords indicate those different aspects. Again, variable declarations, input, output, assignment, selection, and iteration. Data flow diagram or flowchart is a graphical design notation. Its purpose is to identify the flow of data through the program, including its inputs and outputs. Selection and iteration are also highlighted in the diagram. Let's look at this example we have here. We have our terminal, which is start. This will begin the program. We then have initialization of our variable, where we set the variable correct pass to computing. We then move forward to our input, where we get the user password. We then go into a selection statement. Is the user password equal to the correct pass? Yes or no? In the case of no, we then highlight iteration. We display an error as output, and then we iterate back to the input for the user to re-enter their password. This is again checked in the selection statement. User password equals correct pass, yes or no. If the correct password has now been entered, we will move forward to the next terminal, which will stop and finish the program. In our previous slide, where we were talking through the diagram, you may have heard me use words like terminal, initialization, input, selection, iteration. Some of these terms you have heard before, and others you may not, such as terminal and initialization. These words are derived from the 8 symbols that are used in the creation of our data flow diagram. These symbols are displayed on the screen for you now. The flow of the data, importantly, is highlighted using the arrows. Sometimes these diagrams can be quite large, therefore we have a symbol called an on-page connector, which allows you to connect the bottom of one flow to the top of the next. We can now look at these symbols next to our data flow diagram. We can identify where each of these symbols are used within our data flow diagram. There is a small selection of these symbols which haven't been used. Our process, our on-page connector, and our predefined function. Notice the flow of the data is identified using our arrows. Our third design notation is a structured diagram. This is another graphical design notation. The purpose of this design notation is to identify the steps the program must go through to complete the task. These steps are shown as symbols on a tree or hierarchical structure. These diagrams are read from the top down and left to right. Let's look at this example we have. We have the problem of creating a login program. In order to create that, we must break that down into 3 more manageable pieces. Getting our input, checking our input, and displaying the message. Therefore, in order to complete this larger login program, we must carry out these 3 stages in order. So we would get our input from our user. We would then check our input using validation. Once that has complete, we would then display a message to tell the user whether they have been successful or unsuccessful in logging in. Again, there are different symbols that we would use to create a structured diagram. We have our process, predefined function, selection, and iteration. There are 4 distinct symbols that we would use in the creation of this structured diagram. Let's now look at these symbols next to our structured diagram example. In this example, we use two of the symbols. We are missing our predefined function and selection. This is not required for this small, simple program. Notice that we validate using iteration. We would normally use a conditional loop for our validation. Our final design notation is something called a wireframe. These are widely used in application development and also the development of websites. They're used to create the design for a user interface for our application. A wireframe contains a variety of different information for our developer, such as the layout of the interface, which objects will be used, such as buttons, labels, or text boxes. If there are any graphics, which position those graphics will be in, the types of files those graphics will be, and where those files can be located. This saves the developer a great amount of time. Wireframes can be as simple or complex as you like. Generally, they're not intended to be particularly detailed or complex, but all our inputs and our outputs must be clearly represented and shown within the wireframe. Here we can see our initial wireframe diagram and the finished application side by side. We can clearly see each object within the finished application and the corresponding position within our wireframe diagram. This can be viewed on as a map or a layout of our application interface. Thanks for listening. You'll find many more presentations on software design and development and other computing science topics on our channel. Please remember to spread the word to your friends, and also remember to subscribe at Greif High Business and Computing Science.